Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to determine whether a certain mixture or reaction is going to end up having ions in it in order for it to conduct electricity. So let's get into this. So in this problem, when you're given 1.0 moles of solid lead nitrate and that is added to 2.0 moles of aqueous potassium iodide, you're told that a yellow precipitate forms. After the precipitate settles to the bottom, does the solution above the precipitate conduct electricity? So in order to answer this question, we have to know if there's going to be positive and negative ions left in solution. And so in order to do that, we need to figure out, one, does everything completely react? And two, are we going to have electrons left over in the solution? So the first thing we need to do is write out a balanced chemical equation. So we're going to take the fact that they're telling us we have solid lead nitrate. So let's write that down. So solid lead nitrate, that's going to be lead 2 nitrate. Lead has a positive 2 charge usually. So this is going to be Pb, and nitrate has a -1 charge on it. So we're going to need 2 of those to balance the charge. So there we have solid. That's going to be mixed with or react with aqueous potassium iodide. So let's add that. So potassium has a +1 charge. Iodine has a -1 charge. So it's just 1 each in the formula. So Ki is the formula for potassium iodide. Okay, and that's what we're given. We're told that a yellow precipitate forms. So we have to figure out what the products are. So one of the things you should know right away is you should be able to determine what type of reaction this is. We have an ionic compound here, an ionic compound here. So if you have two compounds, especially if they are ionic as reactants, then that's a dead giveaway that you have a double displacement reaction. So to predict our products, we'll take the outside ions, put those together. So the lead 2 with the iodine, that's going to give us Pb I2 for the formula, plus, and then the inside ions go together. So potassium and nitrate are going to go together. So we'll have potassium is a +1, nitrate -1, so it's 1 each. So KNO3. Now, which one is the precipitate? We have to look at our solubility rules. Right away, you should know that usually first solubility rule tells you that all nitrates are soluble. Also, group 1 metals are all soluble. So this is a soluble, so that's aqueous. So by the process of elimination, this must be our yellow precipitate. If you look up the the solubility rules for lead and iodine, it'll say that all the halides are going to be soluble normally, except for one of the exceptions is lead. So lead iodide is not soluble. So that's going to be solid. Okay, next, let's write out the complete ionic equation. So anything that is liquid or solid stays together in your complete ionic equation. Anything that is aqueous is split apart. But before we do that, we need to balance the equation. So we have 1 lead here, 1 lead there, that's balanced. We have 1 potassium, that's balanced. We have 2 nitrates. We only have 1 nitrate here, so we'll have to put a 2 here. So now that our nitrates are balanced, what about potassiums? We got to go back to potassium. So we're going to have to balance potassium here. We'll put a 2. So now everything's balanced except for the iodine. Well, let's check the iodine. So we have 2 I's and we have 2 I's. So everything is balanced. So now let's write out our complete ionic equation. So the lead is a solid, that's going to stay together. So we don't separate solids in our complete ionic equation. This is aqueous, so we're going to split up the ions. So since we have 2 Ki, that means that aqueous means that these ions are floating around. They're not actually together. So we're going to split them apart. So if we have 2 Ki, that means we have 2 positive potassium ions and 2 negative iodide ions. So we'll write that. So 2 K plus aqueous plus 2I minus aqueous. And so now we'll do the products. So this is solid, so that's going to stay together again. PbI2 solid. And then this is aqueous, so we'll have to split these up again. We have 2 KNO3, so that means that we have 2 positive potassium ions, and then we have 2 negative sodium nitrate ions. So this is going to be 2K plus aqueous plus 2NO3 minus aqueous. Okay, so now that we have our complete ionic equation, let's look at what the problem is giving us. So they say we have 1 mole of solid lead nitrate, and we have 2 moles of aqueous potassium iodide. So we have 1 mole of this and 2 moles of this. Now notice right away that the moles they give us match the ratio of the moles in our balanced equation. So the mole ratio between lead nitrate and potassium iodide is 1 to 2, and that's exactly the mole ratio that we have, which means that the solid here will completely react with the aqueous solution here. So we have a complete reaction. So, but don't let that fool you, because even though it completely reacts, doesn't mean that you're not going to have ions left over in solution. So that's the key. Do we have ions left over in solution? So since we have this is going to completely react with this, then basically all of this becomes all of this. So we just need to look at this here. So on this side here, this is what is left in solution after the reaction. So here we have solid lead iodide. So all of the lead and all of the iodide ions are solid. Those are not in solution. But look here, we have potassium and we have nitrate ions in solution. So these are left in solution in the aqueous, in the solution above the precipitate. So because we have ions in solution, it will conduct electricity, because in order to conduct electricity, you need ions that are able to be moved around. And so ions that are dissolved in solution can move when there's an electric current. So the answer is yes, this will conduct electricity. I hope this is helpful. If you enjoyed this video, if you learned from this video, then please by all means like the video, share the video, hit that like button over there somewhere. Also, help me out, subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you need help with, excuse me, I would love to help you with that. If you have a topic you would like me to cover, I can do that for you too. Thanks for joining me, and have a great day.